All right, so let's take a look at loudness. So loudness is the amplitude of the sound wave. It's how much energy the sound wave is carrying. Another word for loudness would be the intensity of the sound. And loudness or intensity, I guess it would be helpful if I uncapped my pen. Loudness or intensity are measured, it's measured in the power per unit area, power over area. So its units are watts per meter squared. Now this is important in understanding why you shouldn't play if you have music playing on your phone in your bedroom and it's just playing out like over the whole room, and then you decide to go for a walk, so you put your earbuds in. You need to lower the volume because in your bedroom, that sound is coming out over a huge area. When you then put your earbuds in, that same loudness, that same energy, that same power is being put over a much tinier area of your eardrum, and you can damage your eardrum. And when our eardrum is exposed to too loud of a sound, they hurt. The eardrums can even be busted if the sound is too loud. Okay? Now we can hear a range of sound. The lowest sound that we can hear is called the threshold intensity. Threshold, it's like the base, the lowest level, the threshold intensity. And its letter is I-O. And its value is 1 times 10 to the negative 12 watts per meter squared. Okay? Any sound, and this is stereotypical. This is assuming that everybody's eardrum is the same, which of course it isn't. But the average, whatever that looks like, person can hear is the lowest sound they can hear. The softest sound is 1 times 10 to the negative 12 watts per meter squared. Anything lower than this doesn't have enough energy to cause our eardrum to vibrate. Okay, so the way sound works, like a voice, is like my vocal cords move, and they move the molecules next to them, the molecules next to them, until finally it reaches your eardrum, and that vibration causes your eardrum to move, and then that's carried by your auditory nerve to your brain, which interprets what the sound is. So the sound wave that reaches your eardrum has to have enough energy to move the eardrum to cause it to vibrate. And so what has been found is that anything with an intensity lower than 1 times 10 to the negative 12 watts per meter squared doesn't have enough energy to cause the eardrum to vibrate. Now, as we get older, this threshold gets higher, right? Because like everything else in our bodies, as we get older, it's harder for our eardrum to move. It requires more energy for our eardrum to move, so we can no longer hear the lower sounds. Our threshold moves up. But this is what is used as the standard threshold for most people. Now, there's another reason why some people can't hear, and I'll get back to it. But if it's because of the loudness, then hearing aids can help. Because what a hearing aid is really like a microphone. It amplifies the loudness, right? And so that then it helps your eardrum detect the vibration more and allows the eardrum to vibrate. Sounds above 1 watt per meter squared cause pain. Okay, so if we hear sounds that are above 1 watts per meter squared, this is sometimes called the threshold of pain. But look at this. This is a huge range from the lowest sound we can hear to when pain occurs. And the range is so large that scientists said, you know what, we need to do something that will shorten up the range. And the something is to use a logarithmic scale. Okay? Now, a logarithmic scale, if you were in grade 11 math in school this semester, you probably would have come to it, I think. What it does is it takes a big, huge scale and it condenses it. So I'm going to put 1 watt per meter squared up here. And I'm going to put 1 times 10 to the negative 12 down here, just because. Okay, so this is our range that we're going to use. But before we even start, find the button log on your calculator. Okay, and if you take the log of 0, to do it, you should get error. If you take the log of 1, you should get 0. If you take the log of 10, you should get 1. If you take the log of 100, you should get 2. I'm going to sneeze. So what the log does is it condenses 1 to 10 to just one place. 10 to 100, that's 90 numbers. They get condensed between 1 and 2. If we go to log of 1,000, it's equal to 3. So can you see how then we're condensing a wide range of values into a much smaller range? So to find out, our logarithmic scale uses the equation 10 log I over I-O. And I-O is this up here. So it compares every sound we hear to the threshold level, and it gives us a sense of how high above that base level that we can hear is the sound that we're listening to. So if we put 1 times 10, and this side is a beta, second letter in the Greek alphabet, and it's giving us the intensity level of the sound, the intensity level as opposed to the loudness. Okay, so it's really giving us a logarithmic ratio of how big one sound is compared to the threshold. So if we were to put the threshold in here, right, so it would be, okay, let me box this so that I don't screw it up. So if we put the threshold in here, it would be 10 log I would be 1 times 10 to the negative 12, because that's the threshold, and I want to see what's the decibel reading, but we're comparing it to the threshold. So this is just going to be 1, right? And log of 1 is 0. And so the decibel reading for the threshold is 0. So instead of having, if we use the intensities, the lowest sound that we hear is 1 times 10 to the negative 12. But if we use the intensity levels, it's 0. So now let's put the pain intensity in. So 10 log 1 over 1 times 10 to the negative 12. And this is watts per meter squared here as well. Okay, so we're going to get 1 times 10 to the positive 12 when you do that division. So now if you take the log of that, you get 12. And 12 times 10, you get 120. So the range then goes, instead of from 1 to the negative 12 up to 1, it goes from 0 to 120. Now the one thing I haven't talked about are units. The intensity level is measured in decibels. That's what I was about to write here, and I stopped myself because I realized I hadn't said it. Decibels. Deci, if you remember from the metric system, is right there beside the base unit, and a bell is named after Alexander Graham Bell, okay, who's the dude that did so much with sound, okay? The telephone is what he's really famous for. All right, so decibels. Now, there is one example there, I believe, on your sheet that we could do. What is the intensity level of sound, of a noise whose sound level is 1 times 10 to the negative 10? So it's telling you I is 1 times 10 to the negative 10 watts per meter squared. So beta is equal to 10 log I over I-O. So 10 log brackets 1 to the negative 10 over 1 to the negative 12. That's going to be 10 times the log of 100. Take the log of 100, get 2 times 10 is 20. This is 20 decibels. Okay, so that's how you use that equation. Very good. No homework with this one though.